Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video I'll show you how to estimate the speed of a vehicle. First we will detect the vehicle, and for that we will use YOLOv8 algorithm. Once we detect the vehicle, after that we will apply a speed calculation formula on it. And guys, if you know the factors such as the acceleration, distance traveled and time elapsed, then you can easily calculate the speed of a vehicle. Okay, this technology can be valuable for various purposes such as law enforcement, where police officers can use it to enforce speed limit and identify vehicles that are speeding. This will help in prevention of accidents and this will ensure the road safety. It can also be used in fleet management. So the companies with vehicle fleets like delivery services, car rental services, or taxi companies, logistics and transportation companies, they can use speed estimation to monitor the driving behavior of their drivers to make sure that they are following company's policies. Also, when fleet drivers know that their vehicle speed is being tracked, then they are far less likely to overstep the speeding limits, right? So this way, this speed estimation app can be useful in various applications. So now let's move to the implementation part. Let's see how to make this speed estimation app. Okay, so guys, for today's tutorial I'm using the YOLOv8 pre-trained model, which is trained on COCO dataset, and COCO dataset have various classes and some of them are car, bus, truck, and we are using these classes. So we are using this model to detect the vehicles. So that's why I've loaded this model, and then in this class list, this is just a list of classes which are there in COCO dataset. So here I'm just creating an instance of tracker class which I'm calling from here. In this line I am just reading the video on which I want to perform the testing. Here we are reading all the frames of the video and then we are resizing those frames to this size. In this line I am using the model which we have loaded above to make detections. So we are making detections on each frame. We are detecting the vehicles from each frame, and then in this variable I am just fetching the bounding box coordinates, class ID and the confidence score. Okay, over here I am creating a data frame. So the reason of creating this data frame is to have all the values in a separate column so that we can easily access them. Let me print this and then I'll show you. So let's print it. So this is the first frame, and just scroll down, and here this is the data frame. These 11 values are for the first frame. So you can see this is the frame, and over here our algorithm detected these 11 objects, and this is the first bounding box coordinate, second bounding box coordinate, third and the fourth bounding box coordinate. This is the confidence score of the object, and this is the class ID. Okay, so if you'll see in the class IDs, you will have 2 and 7 as class ID. So let's see, the 2 class ID belongs to 0, 1, 2. 2 class ID belongs to the car class, and 7 class ID belongs to the truck class. Now this is what this PX is. Now comment it, and now let's write the next part of the code. So this is the next code which I've just pasted. Here I have created a separate list, and in this list I only want to store the bounding box coordinates and the class IDs which are related to car class. So guys, for this tutorial we are just working on a single class. In my upcoming video I will show you how to work on multiple classes, but right now we are focusing on single class only. So for that I have prepared this separate list, and this list will have the bounding box coordinates and the class ID of car class only. So this is how I'm fetching all that data. So guys, here you will see in X1 I am storing the data which is there at a 0 location, and then in row 1 in Y1 what I'm storing the data which is presented this column, and then in X2 I'm storing this data, and in next variable over here I'm storing this data, and we are not storing the value of confidence score right now. and here you can see in D variable we are storing the class ID, and after that next variable is this C and class list in D. So what we are doing, we are just fetching the class names of the IDs which we have over here. So we are getting, if 2 is here, so instead of 2 we want to have a name of that class, car. Okay, so that's what we are doing in these two lines. And if car in C means if over here we have car, then only we want to append this list with the bounding box coordinate, and this is how you will get all the bounding box coordinates of the car class. And next is to use the tracker. We want to detect the object and we want to track the object. Then only you can know the speed of the object if you can track the object. So we are writing the code for tracking, and this is the code I have written. So here we are updating the tracker with the list which we have from here. This list have the bounding boxes of car class. And over here these are the 4 new variables now where I have stored the bounding box coordinates and ID, and we are providing this information from this B box, and it is getting the data from B box ID. And what is there in B box ID? We have updated the tracker over here. Okay, and then guys, the CX and CY, this is the center coordinate of the bounding box. You can see in this image, this is the center coordinate of the bounding box. So we are getting the value of CX and CY. So once we get the value of CX and CY, using this CV2.circle, I want to, for every frame, I want to put a dot in the center of the object. So that's why we are fetching this CX and CY. And with the help of this CV2.rectangle, we want to put the bounding boxes on each tracked and detected object. So that's what we have written over here. Now let's print it and see. We have the bounding boxes and there is a dot in the center. So we are getting the bounding boxes around the object because we have used this, and we are getting circle in the center of each detected object because we have used this CV2.circle, and CX and CY we are getting from here. Now we have the detected objects. Now the next task is to know the speed of these objects. So for that we need to draw 2 lines on the frame, and then I'll show you what logic we will follow to know the speed of the vehicle. So let's draw the 2 lines first. Here we can write that code. So this is the code of first line. I want to create a line on each frame. This one is the starting coordinate of the line, and this is the end coordinate of the line. Why we are having 2 values, x and y value? So for every whenever you want to create a line, you need x and y value. Okay, so x value is from here and y value is from here, and that's why we have this 172 and 198. So 172 means 172 pixels from the x-axis and 198th pixel from the y-axis. In the same way, the end point of the line is 774 and 198, which means 774 is the x value and 198 is the y value. And this red color, okay, so I want the line of this color, so I have the colors over here. So these 4 lines are just for color. If you want to put white color, you can use this variable for red color, blue color and green color. Okay, so my first line will be of red color, and on that line I want to put the text, and the text is red line, and I want to show that text at this location, means the starting point of the line. Okay, there I want to show the red line, and then this is the second line. So for the second line, this is the first x and y coordinate of the beginning of the line, and this is the x and y coordinate of the end of the line, and I want to write blue line on it, and at this location I want to write it. Now let's print it and see. So you can see this is the red line, this is the blue line, and red line is written on it and the blue line is written on it. Now the logic which we will follow is that the vehicle, these detected vehicles, so right now all the vehicles are getting detected, whether the vehicle is over here or here, right? All the vehicles are getting detected. But now we will write a condition that we only want to put the dot and the bounding box on that vehicle which touch this red line. That's it. We don't want to detect any other vehicle. We only want to detect that vehicle which touch the red line. Okay, so we will write a condition now. So the condition is, so now guys, I am just commenting these two lines which are putting circle and the rectangle on the detected object, because we don't want to put circle and rectangle on all the objects. We want to use the condition that if the object touch the red line, then only we want to put the bounding box and the center point on it. So this is my condition for red line. And here guys, this red line, why, what it is. So just see this frame. As I've just explained you, whenever we want to draw any line, we need the x value and the y value. This red line y is the y value of the red line. This will tell you the what is the location of the y line. Okay, so if we want to write a condition that if vehicle touch the red line, then only show the bounding box and the center point on that object. So that means we need to know the location of the red line first, then only we can write this condition. So that's why we are having the red line y value. So these are the three values you need: red line y, blue line y, and the offset. Red line y is the y value of the red line. This will tell you the location of y line, and we need this when we want to write a condition that if vehicle touch the red line, then only we want to show the bounding boxes on it, right? In the same way, we need the value of y of blue line. This will tell us a location of blue line, and we will use it later also. Okay, so the condition is if red line y is less than cy is the center of the object, plus offset, and red line y is less than this cy minus offset. Okay, so this is the condition if object touch the red line. So here I am using a down dictionary. Now let's create a down dictionary first. I'll explain you the code. We have created a down dictionary. This dictionary will store all those vehicle IDs which are touching the red line, and it will also store the location, the position of that object. Okay, let me show you practically. Let's see how it works. So down ID equals to C. So we are storing the current position of the object and the tracking IDs of the vehicle. And if ID in down, if the ID is in down dictionary, then only we want to put the circle in the center and we want to put the ID on the object. So let's print this down dictionary and see what kind of values we have. So I'm printing it. Just a minute. So this is the frame. So here you can see this is the down dictionary. This vehicle is touching the red line. So the ID of that vehicle is 2. And the position where that vehicle is, the current position of that vehicle is 194. And now let's see the second frame. So this is the second frame. In second frame also, the same object is getting detected touching the red line, but this time the position of the vehicle is shifted by 1 pixel. Now let's move to the next one, and then the next one, and let's see few more frames to understand. Now see here. Now on this side, this vehicle is touching the red line and the ID of this vehicle is 0. Now scroll down and you can see the down dictionary of the after the recent frame. So this one is the previous object which touched the line, the ID and the current position of that object, and now in the recent frame, in this frame, current frame, we have 0 ID and the position of the current object. So this is how this dictionary will store all the vehicles which are touching the red line. Okay, but so we don't want to know the current position. What we want to know? We want to know, so for our today's class, what we are doing, we want to know the speed of the vehicle, and for that, instead of saving their current position, we will save the time, the current time they are touching the red line. Okay, so instead of writing this cy, here we will write time dot time. This will give you the time. Okay, now let's print it and see what we get this time. So here you can see ID and the time of that object. Okay, so the down dictionary is storing the ID of the vehicle which is touching the red line, and the time, the current time of the vehicle when that vehicle is touching the red line. Now the same way, let's write the condition for blue line also, that when the vehicle touch the blue line, we want to store the ID of that vehicle and we want to save the time, the current time of the vehicle when it touched the blue line. Okay, so the condition will be same. Instead of writing this red line Y, you just need to write it blue line Y. Let's just copy it and comment it here. This is the condition for blue line. Instead of writing this red line blue, we will write blue line Y. This will give us the position of blue line. And here let's create a new dictionary with the name of up, and here you have to change the dictionary name, and let's create that dictionary over here, up. So okay, so our condition is ready. Here let's print the value of up. This code will show you the ID and the center point on that car which will touch the blue line only. Okay, let's see it. Okay, here now we are just checking the frames one by one. Right now you can see the up dictionary is empty because vehicle is not touching the blue line. Let's keep on testing. This vehicle is coming towards blue line. Let's see that. Now this vehicle touched the blue line and we have a center point in the center and the 0 ID, and when you'll scroll down, and here you can see the ID and the current time. So now we have condition for red line and blue line. Now how we will calculate the speed? The speed calculation formula is speed equals to distance divided by time. So this red line and this blue line, so we know, I'll show you in a minute, that we know that the distance between these two lines is 10 meters. Now the next thing is time. How we will get the time? When we are storing the time, when the car is touching the red line, we are storing the time. So let's talk about this car. This car, when it touched the red line, we get the time, and we will again save the time of this car when it will touch the blue line. I have just shown you the condition that how to store the time of the car when that car touched the red line, and then we have seen how to store the time of the car when it touched the blue line. Now we have to merge these both conditions. So our final condition will be to get the time, because for the speed formula we need the value of distance and time, then only we can estimate the speed. So to get the time, we need to merge the conditions of both line, red and blue line. And how we will merge the condition? So what we will do? So the car, when it touched the red line, we will store the time, and the same car, when it touched the blue line, we will store the time, and then we will minus the time and then we will minus the time when car touched the red line from the time when the car touched the blue line. So we will minus the time and we will get the elapsed time. Elapsed time means the time passed. Okay, so this way you will know the distance and the time, and then you can apply the formula of speed on it. Let's understand for blue line also. So when this car touched the blue line, you have the time, and now when this car will touch the red line, you will get the time. Okay, so from this time, the time when the car touched the red line, we will minus the time when it touched the blue line, and we will get the time elapsed. that time will be used in the formula of speed, and we will know the value. Okay, now let's see how to do it practically. Let's do it with a code. So now I'm commenting this code also, blue line code also, because we are going to merge both the conditions now. So let's do that. So this is for first line. What I have done, let me explain you. First, car will touch the red line. When car will touch the red line, we are saving the time, at what time the car touched the red line, the current time. And then we are putting one more condition, that when car will touch the blue line, we are getting the time of that as well. And from that current time, we are minusing the time when the car touched the red line, and you will get the elapsed time. Okay, then we have a counter down. This counter down, okay, I'll explain you this counter down in a minute. Let's understand this part first, which we have just I have shown you with the help of frame. Let's understand that. So the distance is 10 meters between the two lines. I've told you na, that the distance between the red line and the blue line is 10 meters. So we know the distance, and this, the formula of speed is distance over time. So we know the distance, we have the elapsed time. Now we are using the formula distance over time, and we will get the output in meters per second, but we want the output in kilometers per. That's why we have multiplied it with 3.6, and then we are putting a circle. When this car will touch here, at that time we want to put the circle in the center of the object, we want to put the rectangle also, and then we want to put the ID on it, and here we are also putting the speed in kilometers on it. Okay, so this is the condition for red line. In the same way, if the car is moving from this side, so the car first will touch the blue line and then will touch the red line, and when it will touch the red line, here we will display the speed of it and the ID of it. So car will touch the blue line first, we are saving the time, and then car will touch the red line, we are getting that time. From the current time, we are minusing the previous time when it touched the blue line, and distance is 10 meter. Elapsed time we already get it from here. Here we are getting the speed in meters. We want to convert it in kilometers. That's why we multiplied it with 3.6, and then we are putting the circle in the center of the object, bounding box on the object. We want to put the ID on an object, and we want to put the speed kilometers per hour. So this is the condition. So if you'll see the code, you will notice that I have used this counter up over here in the second condition and the counter down in the first condition. So this counter down is storing all those vehicles IDs which are touching the red line first and then the blue line, and this counter up is storing all the list of vehicles which are touching the blue line first and then the red line. So let's create the blank list here, counter down. So this will store all the vehicles which will touch the red line first and then the blue line, and then we have counter down. This will save all the vehicles which are touching the blue line first and then the red line. So now let's print it, and we also want to show the count on each frame. So for that, let's paste these two lines, put text going down. Here we are getting the length of counter down, and it will be, you can see it in front of go down, and in front of going up you can see the length of the counter up. This will give you the count of vehicles moving upwards and downwards. Even the cars are coming downwards, the car is first touching the red line and then the blue line. When it touched the blue line, over there we see the speed. Okay, in the same way, when car is moving from blue line and then touch the red line, over here we will be we can see the speed in kilometers. Now let's close it and understand it frame by frame. Now let's understand the frames one by one. So this was the first frame. So let's just move to next few frames so that we can see the car. So this car is crossing the red line. When it will touch the blue line, we will see the output. Okay, on the other side you can see here also this car touched the blue line and then the red line, and this is the speed kilometer per hour. And for this car the speed is 41 kilometers per hour. And now let's check this car. The speed is 52 kilometers per hour. And here we are getting the count also going down and going up. And guys, remember we are only working with the car class, so that's why we are not getting the speed of the truck and the other classes. This is how you can perform, this is how you can estimate the speed of the vehicle using YOLO. Link of the code in description section. You can try this code, and I hope this video is helpful. Thank you for watching.